so today we're gonna start by finishing what we had started on Friday, which was a review, or not a review, an example of solving systems of linear equations. The one we did on Friday was a comparison type problem. This problem is a mixture type problem, and we're trying to find the proportion or amount of two different things that are involved in the situation. Right? So this is a mixture type problem. And so here's our context. We have admissions at the fair. The admissions fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people enter the fair. I lost the number here. Let's fix that. People enter the fair, and 5,050 is collected for admissions. How many children and how many adults attended the fair that day? All right, so in this scenario, the question we're ultimately trying to answer is the last thing here. How many children and how many adults attended the fair? So we're looking for two values, not just one. All right, so that gives us two different equations that we can set up. The first equation is for attendance at the fair, like people who went to the fair. So let's say people. Right? And that equation is adults plus children equals 2,200. Number of adults that attended plus the number of children that attended, 2,200. So that's one equation we can set up. The other one is for the admissions, so like the money they made. Right? The dollars. Right, in that case, we have $1.50 for children plus $4 for each adult. Right, and that equals 5,050. So we have these two equations set up. A plus C equals 2,200. Right, we're using C for children, A for adults. Right, so that's the number of people, and we also know how much money was made by those admissions. Right, 5,050. It's $1.50 per kid, and $4 for an adult. Right? Unfortunately, this does not look like the type of equation we've done before, where we have a variable equal to another variable, or something happening to another variable. So what we need to do is kind of rearrange these so that it looks like something we've dealt with before. We're using A and C as variables instead of X and Y, but we can still rearrange those. In this scenario, I'm going to choose to have A, the number of adults, be the variable that's going to be equal to something occurring with variable C. So we'll rearrange the first equation. So we have A plus C equals 2,200. We're going to subtract C from each side. Right, these C's go away. It leaves me with A equals 2,200 minus C. All right, we'll do something similar with this one. Right, we're starting with $1.50. Wrong color. 1.5 C plus 4A equals 5,050. I want A on the left by itself. I'm going to start by subtracting 1.5 C and take the whole thing. All right, that goes away. On the left-hand side, I'm left with 4A equals 5,050 minus 1.50 C. All right, to finally get A by itself, we divide each side by 4. And that leaves me with A by itself equals, what was that? 1,262.5 minus 0.375 C. All right, so our second equation, A equals 1,262.5 minus 0.375 C. This is our system of linear equations. So now we need to solve these. One way to do this is to set the two equations equal to each other. Right? They're both equal A, so I can set 2200 minus C equals 1,262.5 minus 0.375 C. Right, so that's what I'm going to do. All right, we need to solve this for C. So we're going to set these equal. We have 2200 minus C equals 1,262.5 minus 0.375 C. All right, I need C on one side and I need numbers on the other side. I'm going to start by adding C to both sides. The reason I do this is because I end up with a positive valued C on the right-hand side, which is nice. I like positive numbers. So that leaves me on the left-hand side, I have 2200 equals 1,262.5. All right, negative 0.375 plus 1, right, will leave me with a positive 0.625 C. Then I need to subtract the number from the right-hand side, 1,262.5. So I also have to do that to the left-hand side. My number is gone here. I'll be left with 0.625 C. All right. And that will be equal to 937.5 to 0.625 C. Lastly, we divide by 0.625 on each side so that I get left with C by itself over there. 0.625 here. And that leaves me with a nice whole number. 1,500 equals C. This is excellent. I did not end up with a fraction of a child, which is helpful. So we have this 1,500 equals C. So now I need to take this number and put it back into one of the two equations. Okay. I always like to choose the most simple equation. All right. The simplest equation is this one. All right. So what I'm going to do is I'm going to take this value of C, 1,500, and replace this right here. All right. And that will give me the value of A. So this will be A equals 2,200 minus 1,500. Again, that comes from here. Okay. And we get that A equals 700. So on this day, there were 1,500 children and 700 adults at the fair. Right. Now again, I want to emphasize the fact that we had to find A and C. Right? It was necessary to find both of these to find the solution. And again, when you're finding the solution to a system of equations, you need to find both numbers. You need to find essentially the coordinates, the x and the y value, to actually have a solution. It's not enough just to find the x value, which is what we've done in just solving an equation, right? We need to find x and y to have the full solution, right? Now the other option here is we can look at the graph and find the intersection of the two lines. This would be really a little challenging to graph by hand because of the size of the numbers, right? So we're going to look at Desmos. Yeah. All right, I've already got our two equations in. A equals 2200 minus C. A equals 1262.5 minus 0.375 C. And we see the intersection right here at 1500 comma 700. The x-axis is representing C, the number of children. The y-axis is representing A, the number of adults. And the intersection here says there's 1,500 children and 700 adults, where the two lines are equal. Okay, so it's another way of finding the solution. If you do not have access to Desmos or a graphing calculator, doing it by hand is the best route to finding the solution in this case. All right. If you have any questions, please let me know.